Hi everyone, in this video we are going to discuss about frequency channel assigned to Wi-Fi or the wireless LAN, and more specifically we are going to discuss about frequency band which are reserved or which are being used by various standards of IEEE 802.11 standards. So we know that frequency is actually the number of cycles per second, and like other wireless communication standard like mobile communication and satellite communication, they use actually frequency range for transmission and reception. In the same way, Wi-Fi devices or Wi-Fi network also uses frequency for transmission and reception. And so the Wi-Fi devices actually operate in two frequency bands. The range of frequencies is known as band, and band is actually like a water pipe through which signals are actually transmitted and received. Now, Wi-Fi or the wireless LAN or IEEE 802.11 standard, they operate in two frequency bands. One is 2.4 gigahertz and second is 5 gigahertz, and they are collectively known as ISM bands. So ISM stands for industrial, scientific and medical purpose. And now in addition to these Wi-Fi devices, this ISM band is also used by other wireless technologies like cardless phones, Bluetooth devices. So they also use this ISM band. So when we say band, band means that is actually a range of frequencies. For example, when we say Wi-Fi operates in 2.4 gigahertz band, we actually mean that operates in a frequency range, and that range actually extends from 2.40, like you can see here, 2.40, and this goes all the way to 2.4835. That's actually a frequency range in which this Wi-Fi devices operate. So this band, this frequency band, is further divided into sub bands, and those sub bands are known as channels. And now these are the channels which are assigned to these Wi-Fi devices like laptop and our smartphone and access point. So these channels are assigned to them to communicate with each other. Now this band or this range of frequencies are further divided into channels, and the first channel starts at 2.40 here, 2.401, and this goes to 2.423. So this actually makes 22 megahertz. So the first channel occupies 22 megahertz, and the middle of those frequencies is known as the center frequency. So the center frequency, that is the middle of these two frequencies, 2.412, and channel is known by its center frequency, and the channel also is known by its channel number. So like say this is channel number 1. So this first channel is channel number 1, and this, in the same way, the second channel will start after a gap of 5 megahertz. So that channel will start at 2.406 after 5 megahertz. It will start at 2.406 and ends at 2.428. So the second channel is also 22 megahertz in width, and so this is the representation for channel. So this channel is will be identified by channel number 2. In the same way, after a gap of 5 megahertz, we will have a third channel, and that channel will be identified as channel number 3. And the same way, we will have channel number 4, which will start after 5 megahertz gap from here. This is this 5 megahertz gap, and then we will have channel number 4, and in the same way we will have channel number 5. So you can see every channel starts after 5 megahertz from the previous channel, and you can see we have all these channels. But the important point here is that these all channels actually interfere with the channel number 1. See, from channel channel number 1, 2, 3, as well as channel number 5. So this is channel number 5. They all interfere with channel number 1. Interfere means they can step into this one. See here, they are interfering. You can see, so this was the channel number 1, but all these channels are interfering in that channel. And if we operate, or if two devices are operating in the same frequency band, like if they are operating in channel number 1 or maybe channel number 5, then those two channels will be interfering, or those two Wi-Fi devices will be interfering with each other, and they will not be successful. This will be challenging for successful communication between two devices. So now we move further. So we will have channel number 6. Now this is channel number 6, and now this is channel number 6. Interesting thing is that this channel number 6 is not overlapping with channel number 1. If I bring down this channel like this one, so let's say this is channel number 6 here, this is channel number 6, and this channel number 6 actually is not interfering with channel number 1, like this is shown here. You can see channel number 1 and channel number 6, they are not interfering, as well as channel number, you can see channel number 11, they are not interfering with each other. You can see here to this, they are not stepping into this channel. But this channel number 2, this you can see here, this channel number 2, which is starting from here, it means that is starting within channel number 1. So the thing is that in this case we can have 14 channels, but in those 14 channels we can only have 3 channels which will not be overlapping, which will not be interfering with the adjacent or nearby channels. So it means in a common vicinity or in a common basic service set, we can only use these 3 channels without interference. Now there are 14 channels and only 3 non-overlapping channels which can be used. And now in addition to this channel number 1, channel number 6 and channel number 11, let me remove these things maybe. We can also have these channels which are also non-overlapping. You can see channel number 2 and then channel number 7 and then channel number 12. They are also non-overlapping channels. In the same way, if we select channel number 3, channel number 8 and channel number 13, so these will also be not overlapping. So these are 3 channels which are non-overlapping, but we can have 14 channels within this frequency band. Yes, so we discussed that this bandwidth, or the width of all these channels, 22 megahertz. So this will be 22 megahertz when we will be using this DSSS, the direct sequence spread spectrum technology. And if we will be using OFDM, then we will have 20 megahertz wide channel. So the width will be 20 megahertz in that case. Now, although we have 14 channels, but all of the countries, they differ in its use. For example, if you focus on channel number 1, you can see channel number 1 whose center frequency is this, that is 2.412 or 2412 megahertz. So that frequency band is used in Canada, Europe, as well as in Japan. So channel number 1 is used in all these regions. But if we see like in channel number 14, if we focus there, you can see this channel number 14 is not used in US as well as in Canada. This is also not used in Europe, but this is used in Japan. So it means we have all 14 channels, but they are not used in all of the regions. Some of them are used and some of them are not allowed to be used in that specific region. In the same way, in 5 megahertz or the 5 gigahertz band, that's actually contains a range of frequencies, but specifically this contains 4 separate and distinct bands. The first band is from 5.150 to 5.250 gigahertz, and this is the second band, And then we have the third band and there's the fourth band. So that's actually four separate and distinct bands. You can see they are identified as UNII1, UNII2, and UNII2 extended. So I have taken this image from Cisco Press and I have put the reference here. So you can see we have these uh, distinct or separate bands, but these all bands are within this frequency range, that is 5.150 to 5.825. And this UNII actually stands for Unlicensed National Information Infrastructure. But here the important thing is that in this case we have 24 channels, but all these channels are not overlapping with each other. As you can see, they are not overlapping. But in the case of 2.4 gigahertz, those channels are, most of the channels were interfering with each other. But in this case, all these 24 channels are not overlapping. It means we can use all of them. Now, to increase the data rate, multiple channels can also be combined, and this concept is known as channel bonding. For example, one channel is 20 megahertz, and if you want more bandwidth, then we can maybe combine two channels with each other. In this way, we can have 20 plus 20, it means we can have 40 megahertz wide channel for transmission and reception. So in this case, we can use this channel bonding. So channel bonding is a concept where we combine these channels together. Now these are the different IEEE standards which use 2.4 or 5 gigahertz. So let's see which IEEE standards actually use 2.4 gigahertz band. You can see here 802.11, 802.11b, and 802.11g. So these are the standards which actually use 2.4 gigahertz. And then so these are some other standards, IEEE standards, which use 5 gigahertz. And you can see there are some of the standards like 802.11n. This standard uses both 2.4 as well as 5 gigahertz. Now, as per their frequency, as per their band, they have different characteristics. So 2.4 gigahertz is slower. It offers not that much data rate, but 5 gigahertz is faster, and 2.4 gigahertz can cover longer distance, but the 5 gigahertz can cover shorter range or shorter distance, and they can penetrate. So 2.4 gigahertz signals can penetrate building, but for signals operating in 5 gigahertz, for them this will be difficult to penetrate any building. And 2.4 gigahertz actually crowded means other wireless standards, they are using the same frequency band, but this is not that much crowded. 5 gigahertz band is not that much crowded. These are some of the characteristics of Wi-Fi frequency band which are assigned to Wi-Fi or the 802.11 standards. And thank you very much for your time. Hope to see you in some other video.